1 is 207.19 grams. When I add all these together, I will get the molar mass of lead 2 nitrate, 207.19, plus, it's going to double check my math, 16 times 6 is 96, yes, 60 plus, yes, the 96 plus 28, and then I get 331 point. Well, I'm going to just say 331.2 grams per mole of lead 2 nitrate. And what they want to know is how many moles is in 0.250 grams. So I take my given, I'm going to put the work up here now that I found my molar mass. I'm going to take my given, which is 0.0250 grams of lead 2 nitrate, and I'm going to multiply it times 1 mole of lead 2 nitrate over 331.2 grams. And what I'm going to get is 0.025 divided by my answer gives me 7.549. We have only 3 sig figs, so 7.55 times 10 to the negative 5th moles of lead 2 nitrate. And there you go. There is your answer. You scroll down. We say calculate the total number of atoms in the sample. Well, the total number of atoms, there's 1 atom here, there's 2 atoms here, there's 2 nitrogens, and there's 6 atoms here. 1 plus 2 plus 6 is 9 atoms per lead 2 nitrate. See how I counted that up? That's supposed to be a 3. Not a very good 3, but it says 3. So now how many atoms do I have in the sample? Well, here's my amount of moles. I just calculated it right there. So we know that for every mole, if I have 7.55 times 10 to the negative 5th mole of lead 2 nitrate, right, that I can figure out how many formula units I have. So if I have 6.02 times 10 to the 23rd formula units of lead 2 nitrate, a formula unit is similar to saying a molecule, but this is not a molecule because this is an ionic compound. So for every 1 mole of lead 2 nitrate, I have 6.02 times 10 to the 23rd formula units of lead 2 nitrate. That will give me the number of formula units, but we don't want the number of formula units. We want the number of atoms. Now for every 1 formula unit of lead 2 nitrate, please stop moving, computer, I have 1 formula unit of lead 2 nitrate. I have 9 atoms. So this is your equation. It ends up being this number of moles, 7.55 times 10 to the negative 5th, times Avogadro's number, which is 6.02 times 10 to the 23rd divided by 1, times 9, divided by 1. And let's plug that into our calculator. I'm going to multiply that times 6.02 times 10 raised to the 23rd. I get 4.54 times 10 to the 19th formula units, but that's not my answer. Then I multiply that times 9, and what I get is 4.09. I'm going to put my answer in a different color ink here. I get 4.09 times 10, that's a 9, times 10 to the 20th atoms. Come on, atoms. And that's it. That's all it is. Because I could say, like, that's not very good. Let's try that again. Times 10 to the 20th. I'm going to rewrite this whole thing, actually, just so the answer key is a little bit clearer for you to read. Let me just change that again. There we go. 4.02, nope, 4.09 times 10 to the 20th. And my unit is atoms. And I'm going to box my answer. All right, let's go down here. We have number 4B. Given 3.45 times 10 to the 23rd molecules of tricarbon octahydride. Tricarbon means C3, octahydride means O8. If I have 3.45 0.45 times 10 to the 23rd molecules of C3O8. Calculate the number of grams of tricarbon octahydride. What I'm going to do is I'm going to say first, I need to figure out how many moles I have of C3O8. Because I can't convert molecules into grams. I can convert moles into grams. So if I have 6.02 times 10 to the 23rd molecules per 1 mole of C3O8, and then for every mole of C3O8, I have a certain number of grams, that will give me the number of grams of C3O8 that I have. So how do I find the number of grams? You know it. All you do is you find the molar mass. Carbon equals 12 grams per mole, so you multiply that times 3, and that gives you 36 grams. Oxygen equals 16 grams per mole, multiply that times 8, because there's the 8 and there's the 3. There you go. That gives you 80, what is that? 80 plus 42, so 122. 122 grams. When we add those up, we get 158 grams per mole of C3O8. I'm just going to double check my math so I make sure I give you the right answer. You don't have to do this again later. So 16 times 8 plus 36 gives us 164. Good thing I checked my math. That is, let me try that one more time. 16 times 8 plus 12 times 3, 164. Okay, I'm not really sure how I'm doing that wrong. I'm going to pause the video for a second. And I figured it out. It's because I made a mistake, right? I did this in my head and I made a mistake, and that's okay. This is not 122, it's 128, and then 8 plus 6 would be 4, so this is 164. So use your calculator, get good at using your calculator, and now we have the correct grams per mole. So now if I put that 164 grams in here, and I do this calculation, I say 3.45 times 10 raised to the 23rd, and I divide that by Avogadro's number, 6.02 times 10 raised to the 23rd, and I multiply that number times 164. Now I will get my answer, which is 93.9, and there's 3 sig figs, so we're going to say it's 94.0. 94.0, that's a 4. Let's just change that to a proper 4. 94.0 grams. Okay guys, you have to get good at using your calculator, right? You can do some of this in your head, but you're not allowed to use your phone on the quiz or the test. So get good at using your calculator. Limiting and excess reactants. Now these are a bit harder. So here we go. Phosphoric acid reacts with calcium hydroxide to produce calcium phosphate and dihydrogen monoxide. So here we go. This is an acid-base reaction. So phosphoric acid is H3PO4, which is aqueous because it's an acid. It reacts with calcium hydroxide after I balance everything out, which I can also make into an aqueous solution. And what I get is a salt and water. The salt that I get is going to be calcium phosphate, which is a solid. Now when I balance this out, what I need to do is take into account that I have 2 phosphates here, so I'll put a 2 here. I have 3 calciums here, so I'll put a 3 here. Now I have 6 hydrogen plus another 6 hydrogen, so that's 12 hydrogen on the left. I put a 6 here. Now I have 6 oxygen, and I have 6 oxygen here. 2 times 3 is 6. We are balanced. Now if I'm given 0.22 moles of phosphoric acid, 0.022 moles, excuse my misspeaking there, and I have 1.45 times 10 to the negative 2 grams of calcium hydroxide. I have 0.0145 grams of this. I want to figure out which one's going to be limiting, which one's going to be excess. So what I have to do is I have to figure out the molar mass of this, because I need to figure out the moles of my calcium hydroxide. So the calcium weighs 40 grams, the oxygen weighs 16, and I have 2 of them, so that's 32 grams. The hydrogen weighs 1 gram times 2, which is 2 grams. When I add all those up, I get 72. I get 74 grams per mole. Let's just double check my math again so I make sure that this is right. 40 plus 32 plus 2. Yes, it is 74 grams per mole. I convert these grams. Let's do it right over here. 0.0145 grams of calcium hydroxide. And I'm just going to scroll over here a little bit. I'm going to make this a little bit smaller. And I multiply that times 1 mole over 74 grams. And I will get 0.0145 divided by 74. And what I get is 1.96 times 10 to the negative 4 moles. So probably really obvious to you which is the limiting reactant by now. But if I have 1 mole of calcium hydroxide here and I have 74 grams per mole, what that equals is, I'm going to change the color so you can see, what that equals is that number of moles. Now, when I want to figure out which one's limiting, which one's excess, people are going to start coming in this room right now, so I'm going to need to pause this video. I'm actually going to stop the video, and I'll continue this video after, during lunch.